Now let's say the next part about the IP routing technology. We say we have three parts of the routing source: the direct connected routing, static routing, and the dynamic routing. And about the static routing, there are also some principles we have to know. The first one, how many routing entries and the result is correct or maybe incorrect, depends on the administrator, because all the routing information configured manually by the network administrator. So if the network topology change, maybe we add some network segment or maybe some link addresses is broken, the administrator also have to manually modify the static routing information one by one of the whole network. Otherwise, maybe the network addresses still uses the wrong routing table to forward the message, but the network topology already changed. This is the first one. The second one about the static routing information is locally valid and will not be passed on the other routers, because this one routing information only will be added on one devices, and the other devices don't know what entries you have, right? I only forward the information according to the static routing that configured by the administrator, and I will directly send the message to my next hop router, and I don't know my neighbor can, or maybe the other router can help the information successfully or not, because all the devices don't change the routing information between these devices. So this is the second one. And about the third one, static routing is generally suitable for relatively simple network environments. Larger and complex network environments are usually not suitable for static routing. The first reason may be the administrator need to do so many works, right? Because one except the direct connected routing, all the other segment we have to edit on the devices manually. The second one, about the complex network, maybe we have lots of devices, and maybe we usually will change the network topology, and one link maybe delete, maybe edit. We have to add this segment information on all the devices. The working is too busy. So if in some simple scenario, and for example, like the outer devices of the enterprise maybe connect with the ISP, you can use some static route to directly visit the destination. And maybe some access or distribute network topology is very simple. You also can use a static way. Otherwise, we suggest to use a dynamic routing protocol. And the next one, the benefits of using static routes are high network security and confidentiality, because we don't exchange any routing information between the network devices. So maybe some attacker to simulate a layer 3 network device to connect with your network. This attacker also don't get any routing information, right? Because we don't change any routing information between all the network devices. So this one we will get a high network security. And the next part is we have to use a global configuration command, IP route, to configure a static routing information. And this is a command in the configuration page, and the key command is IP route, and then you have to give the destination network and the mask, and also provide the next hop or maybe outer interface, and you can change the distance value. By default, the value is 1. You also can change the value maybe to make the static route to become the backup route or maybe the main route. This is the optional parameters. And the next hop address must be a returnable address on the directed connected network, because when we send out the message and we will match the routing entry and to find the correct destination, and according to the next hop we have to send out the ARP request message to get the correct destination MAC address and do the re-encapsulation again. So if you give the wrong next hop, or maybe the next hop address is unreachable address, you cannot encapsulate the message successfully. So this is very important one. And for point-to-point connections, the next hop address can be replaced by the outing interface. So this is a special application, but by the Ethernet interface, by default the type is broadcast type. So in this scenario, we at least to add the next hop address. So this is some key principle we have to know on the static routing. And about the static routing, we also will have a special topic to talk about the detail. We also have lots of parameters and network design if you want to use a static routing in your network. The target network, mask, next hop address, the outlet interface, and the administrative distance. And the next step is the dynamic routing protocol. The main routing protocol in the current network projects are RAP, OSPF, ISIs, and BGP. And of course, some vendor maybe have some private dynamic routing protocol. But this protocol, this is a normal protocol, and all the network vendor devices can support RAP, OSPF, ISIs, and BGP. And of course, in our RCNA course, we will focus on the basic principle of OSPF, how to work to get the dynamic routing information. And about the ISIs and BGP, maybe in the future we will update this protocol version function on the advanced lanes like the advanced cores like the RCNP. And about the RAP, we will skip it because this protocol usually have some problem. And the first one, all the dynamic routing protocol is used by the routers to calculate and also maintain the network routing information. You can think if we use the dynamic routing protocol, the working process will directly to do like the network administrator to finish the static routing. So basic the same function. But about the administrator, we don't need to calculate and maintain the network routing information, but we still have to enable the dynamic routing protocol on the network devices to add some command. Then all the devices can calculate and maintain the routing information by the network devices automatically. So this one is the big difference. And after getting all the routing information, then we will use a special algorithm and also to calculate finally which routing can be added into your IP routing table. And about this dynamic routing protocol, because of the encapsulation, maybe some work at the transmitter layer, or maybe someone working on the application layer. This depends on the encapsulation. Like the RAP based on the UDP, because we choose the UDP as the transport layer protocol, we will use different port number to indicate the RAP protocol, and the port number is 520. If you use the RAP on IPv6 network, we also will encapsulate into the UDP, but the port number is 521. And about the OSPF based on the IP protocol, and so you can think the OSPF is the transport layer protocol. And About the IP header, we will use the protocol number to indicate different app layer protocol. And about the OSPF, the protocol number is 89. And about the BGP also will be encapsulated into the TCP, and the port number is 179. So when we talk about the BGP on the advanced course, you will find that the BGP protocol can make sure that every dynamic message can be sent out successfully because we use a reliable protocol of the TCP. So this is the encapsulation. RIP, BGP, and OSPF. Of course, they have to encapsulate successfully and add the transport layer or maybe the network layer and data link layer, and finally to be the binary like 1010, finally send out the message. And about the ISIS will directly encapsulate into the data link layer. So you also can think ISIS according to the encapsulation belong to the network layer protocol, but it doesn't matter. But you have to know, maybe you use a tool like the Wireshark to get some packets to say the special port number is 520. That means the RIP already running in your network. So, and now maybe they are exchanging some routing information to maintain your network IP routing table. And about the dynamic routing protocol, the basic function is helps the network devices to get the correct IP routing entry, right? Then the network devices can help us to forward the message according to this table. So how to calculate and maintain the routing table? There are four main steps. The first one, we have to find our neighbor. So this neighbor is special name in the dynamic routing protocol. For example, who I will send some information to this or these devices, and who can receive it, who can recognize this routing information, because we have the special definition of the packets, although maybe we will use OSPF, right? Why they can recognize this segment means the link station, or this segment means the interface IP address, or maybe the mask, something like this. All the devices can receive the message and can recognize these devices we call is our neighbor. So first one, we have to find our neighbor. And how to find this neighbor? Of course, in your network, you have to add a lot of configuration to enable the dynamic routing protocol and to give some special configuration. And the second one, why we need the neighbor? That's because I want to know all the routing information except the direct routing in my IP routing table, right? So I want to get something in my neighbor, and I also want to share something with my neighbor. Finally, I can get the whole network information. I can get the whole topology in our network. So this one we call is a routing exchange. Each router will send its own no routing related information to the neighbor route. And after I get everything from my neighbor, and I will install in some special places, and different dynamic routing protocol have different meaning. Like OSPF, we will receive all the information and then add them into the database, not directly into the IP routing table. About OSPF, we will have special database. And then according to the database, I will use the special algorithm to calculate the best path in the network. Do you still remember the last video? We talked about some administrative and some metric, right? And how to select the best one. Different dynamic routing protocol have different metric. Like OSPF, we will calculate the smallest cost value to become the best one. And this cost value depends on the bandwidth. High bandwidth, the smaller cost value. But about the RIP, we only considered about the router count. Smaller hops, we think the path is better. So finally, we will calculate the best routing information and add it into the IP routing table. And the last step, we also have to do some routing maintenance because your network may be changed, right? Maybe add some link or maybe delete some link. And about the change, the first device is to direct connect with the change link. First one, we have to change my self routing table at first. Then I also have to tell my neighbor that our network is changed, so please maybe add a new information or maybe delete some wrong information. So there are main 4 steps about the dynamic routing protocol. But different protocol, maybe we have different package type and different mechanism to finish these 4 steps. But the whole 4 steps are same with all the dynamic routing protocol. And the key metrics of mention the routing protocols, there are several parameters. That means now I know my network topology is a little complex and we have lots dynamic routing protocol. Which protocol should be used in your network? Lots of scenario we will consider about the 4 parameters. The first one, about the dynamic protocol, you have to provide the correctness of protocol calculation, like the RIP. Why RIP now not be used in lots of network? Because according to the principle, maybe there's some loop, or maybe calculate the path is not the best path. So we want the protocol, the first one can use an algorithm and calculate the optimal routing and a correct routing information without self-loop. This is a basic function. And the second one, we hope that the routing convergence speed is faster. If the network topology has changed, we can quickly sense and update the corresponding routing information in time. This process means, first one, I detect the link is broken now. I will update my routing table as soon as possible. This is the first one. The second one, we hope I can directly or maybe I can send this change information to my neighbor as soon as possible. And the third one, after receiving this change information, all the network devices can calculate or maybe to get the backup link as soon as possible. So if your network topology is changing now, maybe some protocol can quickly get the backup link. So about the user, maybe think that this network time, you cannot send the message out, but the time is very short. It doesn't matter. So this is the second requirement we want the dynamic routing protocol can have. And the third one, about the protocol occupy system overhead. The resources overhead like the memory, CPU, network bandwidth occupied by the protocol itself. Because all the dynamic routing protocol, how to find the neighbor, how to get the routing information, all of them will exchange some packets, right? And in the packets, I will add lots of parameters and send to you. And then you will receive the information that maybe will help you to calculate the routing information. So we hope about this protocol can take less resources is better. But in your bigger network, if you want to make your network stronger to calculate faster, maybe the complex protocol can do it, but take a lot of resources. So this is the third one. And the last one is the security of the protocol itself. For example, we hope that the protocol also can provide some authentication function, something like this about the security mechanism. Not everyone can make the neighbor with me. Maybe I can provide some keywords and to check your information, and then we can to do the next step. Otherwise, maybe some attacker also provide a network device in your network. Then only running the special dynamic routing protocol, and then he can get everything about your network link. So this one is too dangerous. So about the security part, we also hope that we can use some security mechanism. And the last one, the protocol applicable network size, the topology and the size of network in which the protocol can be applied. Also, let's talk about the RAP because we don't have detailed video to see the process of the RAP. About the RAP, in order to avoid the loop, we have some limitation of the hop. I remember the limitation account is 15. So if your network devices is so big and over the 15 accounts, the RAP cannot work. So this is a limitation of the RAP in order to avoid the loop. So these are key metrics when you choose the dynamic routing protocol in your network. So compare this key metric and then we can see the advantage and disadvantage between static routing and the dynamic routing protocol. The static routing advantage is no overhead, simple configuration, because everything will from the network administrator. And the disadvantage is unable to sense topology changes and requires manually maintenance suitable for network with simple topology. Right? So this is static routing. And about the dynamic routing, the advantage is no manually maintenance needed, automatic routing discovery and calculation, suitable for network with complex topology. The disadvantage is how to finish the maintain automatically and discovery neighbor and discovery to calculate the routing information depends on the resources to exchange the protocol packets. So, about this one, we will need high device resources. And also, it's a little difficult to understand the command. If you want to know more function about this protocol, you have to know more principle about this dynamic routing protocol, and also to remember the command, how to add the details command and to finish the function. But about static, it's very easy, right? The same configuration. Maybe the different one is you add 10 static routing information, or maybe 100, or maybe 1000. But the command is same. Or maybe you can change some administrative distance to provide the load balance, or maybe main or backup function, something like this. But the command is very easy. So this is the disadvantage and advantage between static routing and dynamic routing. Then let's see how to do the classification of dynamic routing protocol. We can divide according to the management scope. We can use two classification, one for IGP and another one for EGP. IGP usually likes RAP, EIGRP, OSPF, and ISIS. EIGRP is the private protocol, right? And about this protocol, usually will be used for the campus network and will be deployed in one AS. AS you can think is the special for one organization. And between different AS, different organizations, how to exchange the information, we usually will use the EGP. And now only one protocol, BGP, belongs to the EGP. Mainly used in the finance, government network, and also some career networks. Because about the EGP, later if you know the main principle, how to work about this dynamic routing protocol, and you will know why between this bigger network we will choose a BGP protocol, not about the OSPF or maybe the ISIS. And the classification by the algorithm, we can divide into distance vector routing protocol like the RIP BGP and the link state routing protocol like OSPF and ISIS. This is different scenario. We will use IGP or maybe use EGP. About this one, actually, you only know the classification is enough, because when you do the configuration, you don't need to add the command to let they know you belong to IGP or maybe you belong to EGP, or maybe you use the algorithm is this distance vector or maybe it's a link status, something like this. No, because all the parameters already be done by the protocol itself. You only need to enable like the OSPF, then the OSPF will directly use the special algorithm by itself. You don't need to choose the algorithm. But so about this part, you only know the classification is enough, right? On the configuration, you don't need to add this command to make them, for example, OSPF is IGP. No. But when you do the planning, you have to know OSPF usually will be finished within the autonomous system. For example, belongs to the campus A, and another campus B also can use OSPF. But between these two campuses, if they want to exchange some routing information, then they can do the message exchange, right? Then they can forward the message successfully. All of them need to get the IP routing table at first. But between these two campuses, usually we will use the BGP. So you only know this one is enough. And about the distance vector routing protocol, let's see the characteristic. The routing is announced as a vector. We only focus on the distance and the direction. Distance vector protocol transmits their respective routing table information directly. That means how many entries in your IP routing table, I will tell you everything. But I don't care about that you are the first source devices of the link, or maybe the intermediate, or maybe the last hop. This route doesn't care about these parameters. I only receive the whole routing table from your part, and if finally the information I receive some packets need to visit this destination, I will directly send to you. But I don't care about your next hop. This is not the parameters I want to know. So each router will obtain the routing information directly from the neighbor. And I receive it, I will directly send everything to my next neighbor. And this is passed hop by hop to reach the whole network synchronization, right? And then each router will receive, because I only get the result that from my neighbor, but I don't know the whole network topology, how many routers on the network, and what's the main bandwidth on the devices, or maybe what's the link number. I don't care about. I only know the routing information from my neighbor. So we only know about the network directly connected to them and update their own routes based on the routing information they get from the neighbor. So we only considered about the distance, how far, the vector in which direction. I will exchange this information for one router and to another router, or maybe I will receive from my neighbor from the other interface, the other directions. So in this scenario, maybe there is a loop, but we don't know it. And all the routers will directly exchange the routing table. So that's why if you use a RIP in your network, maybe it's very easy to get the loop. But BGP also belongs to this algorithm. But BGP maybe it's nearly impossible to get the loop, because on the BGP we have lots of mechanisms to avoid the loop. And about the RCNA course, we only focus on the link status routing protocol is enough. If although the same topology, but if we run the special for the link status routing protocol like the OSPF or ISIS, we can avoid the loop. That's because first we will use the algorithm is shortest path first SPF algorithm. And this one based on the digits cluster algorithm, which is more complex than the distance vector routing protocol. Of course, you don't need to add the configuration to choose which algorithm you use. You only to use the dynamic routing protocol to enable it. When they get the routing information or maybe the link status, they will use the algorithm automatically. And the router does not pass the routing table entries directly to the neighbor, but informs them of the link status. Maybe someone say, what's the detailed information of the link status? The link status information includes the IP address of the interface and also includes the mask, the network type, the link overhead, and all the neighbor routes on the link information. So we can know the detail. And the main working process, first we have to find the neighbor. Who is the neighbor? If we're running the same protocol and then I send the message, we will to do the negotiation, and every parameters we check is ready. Then we can be a neighbor and make your information add into the neighbor table. And then between the neighbor, we will directly select the link status information of all the routers in the region. And this link status finally will be added into the database. Then, according to the database, we will use the special algorithm SPF to calculate the routing information. What means the different database and the routing information? On the database, you can generate the network topology. You know the whole network topology, how many routers, how many IP segments you can know, what's a mask, what's the cost value, what's a metric, something like this. And then each router will calculate the routes based on the topology. And we can select the path according to my site. If I am the first router to visit this destination, which path should be better? But about the RIP, how to find the best path? According to my neighbor told me is the best path, right? So this is a bigger difference. They can directly to exchange the link status bidirectional. And if I receive the information from my neighbor A, I can send the same information to neighbor B, but I will not send the same information to neighbor A again to avoid the loop. So finally, all the link status will be added into the topology database and use the SPF algorithm. Finally, we will calculate a path without the loop. So this path finally we call it shortest path priority tree. Someone may be a little familiar like the Spanish tree, right? But about the STP protocol, we use in the physical layer to avoid the loop. But about the link status protocol, the network layer, we also need a no loop. And then the best path will be added into the routing table. This is the whole process. Of course, when we talk about the detailed dynamic routing protocol of OSPF, we can see the detailed step, how to find the neighbor, establish the database, and how to calculate the best path based on the link status information. So that's all about the IP routing technology, and this video is very important. That's because about this video, you will know the main function of the IP routing table and what's the function of IP routing table. The IP routing table is the most important one to let the network devices forward the message between different IP segments. The second one, how to add the IP routing entries into the table. We have three types, right? Direct connected route and the static route. The third one is dynamic route. And about the static routing and dynamic routing protocol, they have different advantage and disadvantage. And about the dynamic routing protocol, we also have different classification, and the different algorithm will be used for different dynamic routing protocols. So this is a basic understanding if you want to deploy some a little complex protocol in your network. And later, the next part, we will explain the detail, how to give the direct routing information, how to give the static routing information, how to give the OSPF configuration, and what's the main step.
Hello guys! I think now you already know the detail of IP routing technology. And we know that in the IP routing table, we will have different type of the direct routes, static routes, and dynamic routes. And about the dynamic, we also have lots of protocols like OSPF, ISIS, BGP, and so on. And in the routing table, how to forward the message out, we will have several parameters. What's the destination, what's the mask, the next hop, the out interface, and the metric, and the priority. So how to select the best route add into the IP routing table? We will compare lots of parameters. First, we will check the destination is same or not. Of course, if you have lots of routing information. And if the destination is same, we will compare the administration parameter. And the next hop, we will compare the metric. And finally, we will add the best path into the IP routing table. And when we forward the message out, we will have the principle, the longest mass matching. We will select the best path and then to forward the message out. So this is the main part of the IP routing technology. And of course, how to add this route into the routing table, how to add the configuration, we will explain on the other videos. Thank you.